Dear students, welcome to the 6th chapter of Science and Technology Part 1, Refraction of Light. In this video, we will discuss about refraction of light, laws of refraction, refractive index and dispersion of light. Refraction of light, the phenomenon of change in the direction of propagation of light as it passes obliquely from one transparent medium to another is called as refraction of light. Refraction occurs because the velocity of light is different in different media. We know that light always travels in a straight line, but when it is passing from one transparent medium into another transparent medium, there is a change in the direction of propagation. This is simply called as refraction of light. Now let us look at the following diagram. In this diagram, you will see that a pencil is dipped in water, but when we see the pencil, we see that the pencil is bent. Now this is due to the refraction of light. When the light rays comes from the pencil from water to air, water is also transparent medium, air is also transparent medium. So when the light rays are coming from water to air, means from one transparent medium into another transparent medium, there is a change in the direction of propagation of light, and that's why we see that the pencil is bent. Actually, the pencil is not bent, but this phenomenon is only observed due to refraction of light. Now we know what is meant by refraction of light. Now we will try to learn the laws of refraction of light. Means whenever the light passes from one transparent medium to another transparent medium obliquely, there is a change in the direction of propagation. But there are the certain laws regarding the refraction of light. That laws we are going to learn in this section. Law number 1. The incident ray, refracted ray and normal lie in the same plane. Rule number 2, the incident ray and reflected ray are on the opposite side of the normal at the point of incidence. Now in this case, we must know the incident ray, refracted ray and normal. Incident ray is that ray which get struck on a surface. In this figure, you will find that this ray is a incident ray which is striking at the boundary of the media. After striking obliquely on this boundary, there is a change in the direction of light. This ray which a changed direction, it is called as a refracted ray, while this one is the normal. Rule number 3. For a given pair of media, the ratio of the sine of the angle of the incidence to the sine of the angle of the refraction is constant. This constant is called as refractive index. When the incident ray falls on the boundary surface, there is a formation of angle between the normal and the incident ray. This angle is called as a angle of incidence and it is indicated by I. When the light ray is refracted, there is a angle between the normal and the refracted ray. This angle is called as a angle of refraction. They are indicated as sin I and sin R. According to the definition of refractive index, the ratio of sin I to sin R is constant, and this constant is nothing but refractive index. Means The refractive index is nothing but it is the ratio of sin I to the sin R, means sine of angle of incidence to the sine of angle of refraction. In order to learn about the refraction of light, we must know some useful terms. Number one term is angle of incidence. The angle made by the incident ray of light with the normal is called as angle of incidence and it is denoted by I. Now in this figure you will find that when the incident ray is striking with the surface, there is a formation of angle between the normal and the incident ray, and this angle is called as a angle of incidence. The second useful term, it is angle of refraction. The angle made by the refracted ray of light with the normal is called as angle of refraction. It is denoted by angle R. In this figure you will find that when the incident ray is refracted, means when there is a change in the direction of propagation, that ray is called as a refracted ray. This refracted ray, it makes angle with the normal, and this angle made by refracted ray with the normal is called as angle of refraction. These two terms are very useful in order to understand the refraction of light. In this topic, we will learn about the refractive index. One thing we should know that the refractive index of different media is different. Now let us learn the definition as well as how to find out the refractive index of the different materials. The refractive index of material depends upon the relative speed of propagation of light in different media. For a given medium, the refractive index depends upon the color of light, that means frequency of light. And again we know that the velocity of light is different in different media. That's why due to this difference, the refractive index of different materials is different. So let us discuss about the definition of refractive index. The refractive index of second medium with respect to the first medium is defined as the ratio of the magnitude of the velocity of the light in the first medium to the magnitude of the velocity of light in the second medium. In shortcut, we can say that the refractive index of any medium can be calculated by using their speed in different media. Now let us find out the formula. Let the velocity of light in medium 1 is v1 and the velocity of light in medium 2 is v2. The refractive index of second medium with respect to the first medium, it is given like this one, twice n1, which is equal to the ratio of velocity of light in medium 1 to that in medium 2. Now let us summarize this in the form of a formula. The formula is like this one. Now we have to find out the refractive index of second medium with respect to the first medium. Now this is nothing but it is a simple ratio. Velocity of light in medium 1, which is nothing but it is the velocity of light in medium 1 is v1 to the velocity of light in medium 2, that means v2. Now it is nothing but it is a simple ratio to the sine of angle of incidence to the sine of angle of refraction. So the refractive index is given by sine I upon sine R. Now this can be read as the refractive index of second medium with respect to the first medium. Similarly, the refractive index of medium 1 with respect to medium 2 can be calculated by the formula. The formula is like this one, refractive index. Here this term will be read as refractive index of first medium with respect to second medium. The formula is velocity of light in medium 2, that means V2, divided by velocity of light in medium 1, means V1. In this topic, we will learn about the refraction of light in different media. When light is going from one medium to another medium, how its direction changes or how the angle changes, we will see the three conditions. Number one, when light goes from rarer medium to denser medium, air is a rarer medium while the water or glass is a denser medium. So, when a light ray passes from a rarer medium to a denser medium, refracted ray bends towards normal. In this figure you will see that when the incident ray is passing from air, which is a rarer medium, to the denser medium, means glass slab, what happens? There is a change in the direction of propagation, means there is a refraction of light. But the refracted ray, it bends towards the normal. This happens when the light ray is going from a rarer medium to denser medium. The second condition is as follows. When light rays are passing from denser medium to rarer medium, when a light ray passes from a denser medium to rarer medium, the refracted ray, it bends away from the normal. This can be explained with the help of the following diagram. In this case, you will see that the incident ray is coming from a denser medium, which is nothing but it is a glass slab. When the incident ray is strike on this surface, the refracted ray is moving away from the normal. It is bending away from the normal. This happens when light rays travels from a denser medium to rarer medium. Third condition, when a light ray is incident normally at a boundary between two medium, it does not change its direction and hence does not get refracted. Means when the incident ray makes the angle of 90 degree with the normal, then there is no refraction of light. The light ray goes without changing its direction.